Swadee krab. Good morning, good afternoon, whichever time zone you may be living in right now. I hope everyone is having a good day. And welcome to the presentation of our senior project, Find the Song, a music identification system by user input. My name is Moakh Kiengsiri, and I'm here with my friend Pitawat Kulkraijak. We're from the Department of Control Systems and Instrumentation Engineering, but we decided to do this project because both of us are musicians. And without further ado, we will now start the presentation. To give you a basic idea of what our project is, I would like to ask the following. Have you ever heard of Shazam or SoundHound? They're both music identification systems with each of their own limitations. Shazam can only be used on official music audio. This means that you cannot identify songs using cover versions or user input. On the other hand, SoundHound can handle user inputs, but their database is very small and do not include Thai songs. From this, there are three main problems that motivate our project. First, the desire to search for foreign songs. Sometimes we don't know the lyrics because it's in a foreign language. Second, the problem of simply forgetting lyrics. And lastly, we've seen many people go on internet forums and ask for songs by using random words to convey melodies such as la 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 da da da, and that doesn't really help. These problems call for a solution, but we're not the first one to do it. There's research all over the world regarding this topic, especially in Korea. I think because the whole world listens to Korean music, so people from different countries want to identify Korean songs. The first three of our references are Korean research papers. After researching, we came across the QBSH system. QBSH stands for Query by Singing and Humming. This is the system we're building as a solution to the problem. There are two main parts to the system: the pitch extraction module and the matching engine.
Here is the overview of QBSH system. So, let's see in this diagram. You can see that this diagram is divided into two parts. The left side is about a database sources, and the right side is about the input from user query. When both music database and input from user query coming into the system, they have to be extracted from audio file to be list of fundamental frequency by pitch extraction process. After that, they will be sent to matching engine process to find the closest song, sending out by the list of song name. Project scope. Having a QBSH system that can deal with audio files. 3 query types, which is singing, humming, and whistling. Minimum 10 songs in database, which is in the different style. Our input queries are in about 12 seconds. The accuracy of our system about 60% evaluated by MRR, which is stand for mean reciprocal rank, and 70% from top 5. To do this project, we create the methods into 6 tasks, which are Task 1, prepare the database. Task 2, investigate extraction and matching tools. Task 3, toy problem and DTW test. Task 4, Phase 1 and IPA test. Task 5, combine and build full QBSH system. And Task 6, Phase 2 and MRR test.
The first task is to prepare the database. For all 10 songs, we need the MIDI files to be used as ground truth, and then a few sine wave audios, some pianos, some full bands, and 3 types of query, which are singing, humming, and whistling. The second task is to investigate the extraction and matching tools. For the extraction tools, there are 5 MATLAB algorithms and 1 Python algorithm. For the matching tool, we investigated DTW, which seems to be the only one mentioned in the research papers. The third task, in order to not waste time, we built a simple system and implemented on toy problem, because we don't want to lose time doing trial and error on 3-minute songs. So we tried to match simple 10-second sequences. This was done on both MATLAB and Python, and we were able to verify DTW as a capable matching engine.
Task 4, Phase 1 and RPA test. This part we have to test all 6 investigate algorithms and choose the most appropriate one. For choosing pitch extraction tools, we use RPA, raw pitch accuracy value, to evaluate them. This is the example of RPA table. For each method, we do it in 3 times and with totally different comparison. Our criteria of comparison are 1. Fundamental frequency vs absolute of difference. 2. Mod of fundamental frequency vs absolute of difference. And the last one, mod of fundamental frequency vs the minimum between absolute of difference and 12 minus absolute of differences. To find the most accurate method, we pick only 3 songs from 10 songs, which is totally in different style, taking the RPA test. And following the table in this slide, you can see that Crep is on the first rank, so it means Crep is the most accurate method to use for pitch extraction process, for both music database and query input from user. Task 5. After we have done with choosing our tools, it's time to combine and build our full QBSH system. So we decide to use Google Drive as a music database and put everything on cloud and build full QBSH system on Google Colab, which is making us easy to work together during this situation.
After phase 1, we had to expand our system. This includes the new index system that checks the database and extract all the unextracted files. Next, after building a full phase 2 system, we do a complete MRR test. This is to finally evaluate against the requirements from the scope. This is an example of the MRR table. The green cells represent the first rank, or the correct matches. We didn't put the full table here because everything would become so small and you wouldn't be able to see, but here's the summary of the results. The top 5 MRR is about 60%, which is still 10% lower from our requirement, so we need some improvements. And now we're still currently in phase 2. The expected outcome in phase 3 would be a more sophisticated system that can achieve all the requirements from the scope. We're not building a full-blown application or anything like that, but we want to try to make it into a web service and put it on the internet for people to use.
Finally, we want our QBSH system achieve the minimum requirements that we have talked in the project scope. This is our reference and it is our team. Thank you for your attention.